Here are the solutions to the AP Practice Worksheet 16 to 28. So go ahead and pause the video and take a look at your answers, and then I'll go over them. In number 16, we're given a position function describing how a particle moves along the x-axis. Position is given at time t. Notice it says A and B are constants that are not equal to each other. So for which of the following values of t is the particle at rest? We know a particle is at rest when the velocity is equal to 0. So in this case, it's equal to x prime of t. So we have to determine that and set it equal to 0. So first, before I find x prime of t, I just want to expand x of t. So this is going to become t squared minus bt minus at plus ab. And again, a and b are constants. So now b of t, which is equal to x prime of t, is going to become 2t. Keep in mind, since a and b are constants, we're treating them just like coefficients. So we're going to get a minus b minus a, and then the last part is a 0. I'm going to set this equal to 0 and solve for t. So I'm going to add a and b to both sides and then divide by 2, and then there's our answer. So b is t equal to a plus b all over 2. In 17, we're given a graph of f, and we're also given a function right here. It's asking which of the following could be the graph of y equals g of x. Notice this is g of x, but over here it's g of t. How could we get this x as its upper boundary into where that t is? Simply by taking the derivative. So that tells us g of x is equal to the derivative of f of x. And if we look up here, this is nothing more than the slope of the tangent line to the graph of f. Well, if you notice, the graph of f is linear, so all the slopes that we write in here, they're going to be the same, so it's going to be a constant, because remember, when you take the derivative of a linear function, you get a constant function. And then also take a look that all of these slopes are positive, so we're looking for y is equal to a positive constant. And it looks like A matches that. B is close, but B is equal to a negative constant here. So it is going to be A. Just looking at the others, these all fail to be a positive constant. C is also linear. D and E are not linear, not constant. So A is the correct answer for 17. All right, 18. We've seen a lot of these problems in the past. This expression that's written here is nothing more than the limit definition of a derivative. And we pull information from it. So it's really asking, what is f prime of 4? So first we need to figure out what is f of x. And we go to this last part here, because remember, it's f of x plus h minus f of x in the numerator. So this is f of x with the 4 out of there. So we would just say it's equal to the natural log of x. Then f prime of x would be equal to 1 over x. And f prime of 4 would be equal to 1/4. So our answer here is B. Okay, 19, given a function that's a quotient here, what points x, y on the graph of f have the property that the line tangent to f at x, y has a slope of 1/2? So we want to know where the slope of the tangent line, which is f prime of x, is equal to 1/2. So if we find the x values, then we can find the y values here. So I need to use the quotient rule to help me find my derivative. F prime of x is going to equal low d high, so x plus 2 times 1. Minus high d low, so x times derivative of our denominator is just 1, all over the quantity x plus 2 squared, and then that's going to equal 1/2. So simplifying this, I'm going to get x plus 2 minus x over the quantity x plus 2 squared, that equals 1/2. In the numerator, the x's cancel, so I have 2 over the quantity x plus 2 squared equals 1/2. I'm going to cross multiply, so I'm going to get 4 equals this quantity squared. Now when I go to take the square root, I'm going to have a plus or minus 2 involved with the problem. So now x is going to equal 2 values. When this is a positive 2, subtracting 2, x would be 0. If this is a negative 2, minus a 2, x would equal negative 4. So I have the two x values here. Now if you notice, because it is multiple choice, there's only one answer that has those two x values, but just in case this was a free response question to show you how to finish this problem, we go back to f of x equal x over x plus 2, so we'll say f of 0 is just going to equal 0, and then f of negative 4 will become negative 4 over negative 2, which is 4, so, I'm sorry, 2, which tells us we have the two ordered pairs of 0, 0, and negative 4, 2, so that's giving us C. All right, 20 is asking for the derivative of an inverse function. So we were working on this not too long ago. Notice here it says g is the inverse of f. So if g is the inverse of f of x, then g prime of 1 is asking for the derivative of the inverse of f of 1. And going back to that formula, this is equal to 1 over the inverse or the derivative of f, the inverse of f of 1. So we first need to figure out what this is, and we're going to go to this point to help us out. So if f of 0 is equal to 1, then the inverse of f of 1 is equal to 0. We simply switch around the ordered pairs and use the inverse notation. So now this becomes 1 over f prime of 0. Now we have to figure out what f prime of 0 is. So f prime of x, we go back to our function we're given here. We're going to use the chain rule. F prime of x is equal to 3 times the quantity 2x plus 1 squared times 2, which turns into 6 times the quantity 2x plus 1 squared. And then f prime of 0 will become 6 times 1 squared, which is 6. So now this turns into 1/6, which is D. All right, now 21, the line y equals 5 is a horizontal asymptote. So horizontal asymptotes can be found a couple different ways, but remember they're connected to limits at infinity, so either positive or negative infinity. So what we could do is write out the limit to each one. So for A, we could use a variety of ways to reason through this. So we'll just say it's the limit as x increases without bound of sine of 5x over x. Now, picture the graph of sine of 5x. The amplitude isn't changed, so the y values are going to range between -1 and 1. So as x keeps increasing, because that 5 only affects the period, so as x keeps increasing without bound, those y values are just going to stay between -1 and 1, but our denominator is going to keep increasing without bound. So this is actually going to give us a 0, so that's not A. For B, y equals 5x, we really don't even need the limit here. That's a line with a positive slope. So as x keeps increasing without bound, so does y. So it's definitely not going to have, if the graph of y equals 5x has no horizontal asymptotes. For C, the same thing here. The limit as x increases without bound, 1 over x minus 5. Again, as x keeps increasing without bound, this is just going to turn into a 0. Now for D, we have an x in our numerator, so as x keeps increasing without bound, we could do the little trick here where we divide by the largest power of x, but here I'm not going to rewrite, actually I will, I'll write this out, but we could use L'Hopital's rule here and take the derivative of the top and the bottom, so this will just give me a 5 over a -1, so this actually gives me a -5, so ruling out the first 4 gives us e. But if I do the same technique for the limit here, I could take the derivative, because right now we have an indeterminate form, so this becomes the limit as x increases without bound of 40x minus 1 over 8x. And I still have an indeterminate form, so I'm going to do this one more time. And this will give me 40 over 8, which is now 5. So reinforcing that E is the correct response. All right, for 22, here we have a function f of x equals natural log of x over x. What is the absolute maximum value of f? So again, this involves working with the derivative, so let's go ahead and find that first. Again, we want to use the quotient rule, but before I do anything else, I want you to notice, even though it's not given to us, we still need to know that with this function having a numerator of the natural log of x, x has to be greater than 0, so we need that to help us out here. So taking this derivative using the quotient rule, we'll get low d high, so we get x times 1 over x minus the natural log of x times 1 all over x squared. So this just turns into 1 minus the natural log of x over x squared. So we know to find our critical numbers, we need to first set f prime of x equal to 0. This is going to happen only when the numerator is equal to 0. So when 1 is equal to the natural log of x, and then this is actually going to be e. We know the natural log of e is 1, but if not, we could just use a base of e on each side and we still get the same thing. So e is equal to x. F prime of x is undefined, when our denominator is equal to 0, so when x is equal to 0, but because we pointed this out right here, x has to be greater than 0, so our function, our derivative is never undefined. So next what I want to do is make a number line for the derivative. Start at 0 and then e. And then I just want to pick some values. Now remember, e is equal to a 2.7, so let's say I test the number 1 into the derivative right here. So I'm going to get a 1 minus natural log of 1 is 0 over 1, so that's positive. And then let's say I test a 5. Now here, even though it says no calculator, if you just want to check real quick, the natural log of 5 is like a 1.6 number. So if I do 1 minus 1.6, that's negative over a positive, so I'm going to get a negative value here, which tells me, now even though we're looking for an absolute max, we're not given a closed interval, but that's okay because we only have one critical number, and on one side of that, our function is increasing and then decreasing, so we actually have an absolute max when x equals e. But it wants to know what is the absolute max, so we need the max is actually f of e, which becomes natural log of e over e, which is 1 over e, so that's giving us b. And for 23, p of t is just a function. It's representing the size of a population at time t. Which of the following differential equations describes linear growth? So if we're looking at linear growth, that means, say p of t is linear then the rate of change needs to be constant. So that's the best way to connect these two. So we're just looking for dp over dt to equal a constant, which is a. 24, g of x is given to be this function here. K is a constant. For what value of k does g have a critical point at x equals 2/3? So again, this involves finding the derivative. This does require quite a few steps. I'm going to run into the next problem here. But still let me know if you have any questions once I'm done going over this. So g prime of x, I use the product rule here. So I'm going to have uv prime, so it becomes x squared times e to the kx times k, because just of e to the kx right here, the derivative is going to be itself times the derivative of the exponent, plus e to the kx times 2x. So that's vu prime. So cleaning this up, I'm going to write the constant first. So we're going to get kx squared e to the kx plus 2x e to the kx. So I know that g prime of x, if it has a critical point at 2/3, we could say g prime of 2/3 is going to equal 0. So this means wherever I see an x, I'm going to plug in or substitute in a 2/3. So I'm going to say 0 is equal to, I'll say 2/3 squared, then I'll put the k, e to the 2/3 k, plus 2 times 2/3 e to the 2/3 k. So now this will give me 4/9 k e to the 2/3 k plus 4/3 e to the 2/3 k. Now I'm going to factor out a 4/3 e to the 2/3 k. This will leave me with a 1/3 k plus 1. So look carefully at that. If we distributed this back in, we would get the previous step. Now I'm going to set each factor equal to 0, so 4/3 e to the 2/3 k. If I try to set that equal to 0, nothing would cause that because this is an exponential function right here, so we won't get any values of k from here. So 1/3 k plus 1, we set that equal to 0. 1/3 k is going to equal -1, multiply both sides by 3, so k is going to equal -3. 25. Which of the following is a solution to the differential equation dy over dx is equal to 2 sine x with the initial condition y pi is equal to 1? As far as differential equations go, I think this one is pretty basic. We don't have any e's involved. We don't have to deal with any absolute values, which is good. So I'm just going to start with separation of variables. Multiply both sides by dx, so we'll get dy is equal to 2 sine x dx. Take the integral of each side. So we're going to get a y plus 1 constant. Now over here, the antiderivative of sine x is a negative cosine x, and I still leave this 2 here, so I'm going to get a -2 cosine x plus another constant. So if you notice, three choices have that negative 2 cosine x. We're going to bring the constants over to one side, and then we have to use the initial condition to help us find that. So with the initial condition, y of pi is equal to 1, so I'm going to get 1 is equal to negative 2 cosine of pi plus c. So cosine of pi is negative 1, so 1 is equal to 2 plus c. C is equal to negative 1, so that gives us e as our answer, y equals negative 2 cosine x minus 1. Right, now 26 was a little tough, but let's take a look at this here. Again, we're dealing with an exponential function, so one thing we should know about this, no matter what exponent, positive or negative, we have a base of e raised to, it's always going to be a positive value. So think of the graph of like y equals e to the x and then y equals e to the negative x, and we're dealing with the same situation here. So I'm going to write this out. E to the negative t squared is positive for all values of t, which tells us if we looked at this interval from 0 to 2, so I'm going to say that this implies that g prime of 2, which would be the integral from 0 to 2 of e to the negative t squared dt, is also going to be positive, again, because this expression is positive. Let me put that in here as positive, so greater than 0 for all values of t, therefore g prime of 2 is also going to be positive. So this tells us if this is the derivative, this means that g is increasing on this interval from 0 to 2. So we know it's either going to be A or B for this one. Now we have to figure out the concavity, so I'm going to take the second derivative of g of x. If I go up here, this is where I'm going to replace the t with the x. So this is just going to equal e to the negative x squared, which is also always positive for all values of x. Therefore, g is concave up on the interval from 0 to 2. So we're looking at g is increasing and concave up, which gives us A. 27, we're given one function here, and we're asked to find the second derivative, but notice already here we have a first derivative in here. So again, we're looking at the 0.30, so we have to do a little bit of work here. I'm first going to get dy over dx by itself. So I'm going to say dy over dx, I'm just going to multiply the 2x minus y times the quantity x plus 2y. Then I want to evaluate this at the 0.30, so I'm not working with such a big expression here. So at 30, dy over dx is going to equal 2 times 3 is 6, minus 0, times, I'm going to get 3 plus 0, so it's going to equal 18. I'm sorry, that shouldn't have been multiplied. I'm going to go back and change that. It should have been 6 over 3, which is 2. Alright, so we're going to actually have 2x minus y over x plus 2y. So at 30, now we're going to have 6 minus 0 over 3, so this is giving us a 2. Now we're good to go. Alright, so now looking at this expression, I'm going to go ahead and find the second derivative. Again, using the quotient rule here. So I'm going to have low d high, so we're going to have x plus 2y. Now keep in mind, because we have a value here, dy over dx, we still needed to use this here. So when I go to take the derivative of the numerator here, I'm going to get a 2 minus, really dy over dx, but I'm just going to write it in as y prime. And then minus high d low, so we're going to have 2x minus y. And then we have 1 plus 2y prime. And then this is all over x plus 2y, that whole quantity squared. Alright, so now again at 30, I can write in all these values, so keep in mind this is also y prime, the dy over dx. So at 30, carefully evaluating this, we're going to get 3 for this first expression, and then 2 minus 2, which will just give us 0. So I'll just write this in here. Minus, again, we're going to get 2 times 3, so we're going to get 6 minus 0, so 6. And then 1 plus, this is 2 times 2, so we're going to get 5. All over 3 plus 0, so we're going to get this all over 9. So what we end up getting here is negative 39ths. Just keep going across. Or negative 10 thirds, giving us A. All right, then the last one, for all t values greater than or equal to 0, the position of a particle moving along the x-axis. Again, we're given a position function. But now we're asked, what is the acceleration of the particle at the point where the velocity is first equal to 0? So we know that acceleration is the derivative of velocity, which is the second derivative of position. So let's go ahead and find the first and second derivative here. So if x of t is equal to sine t minus cosine t, x prime of t, which is our velocity function, is equal to cosine t minus a negative sine t. So this becomes cosine t plus sine t. And then acceleration is equal to the second derivative. Still even put in the first derivative of velocity. So this is going to equal a negative sine t plus cosine t. So in order to figure out the t value we need to substitute in here, we have to take the velocity function, which is cosine t plus sine t, set it equal to 0 to figure out where it's first equal, at what t value it's first equal to 0. So we'll say cosine t is going to equal sine t, negative sine t. All right, so think on the unit circle. We're at the pi over 4 families here. So cosine and sine are opposite in quadrants 2 and 4. So this is going to happen when t is 3 pi over 4 in the second quadrant, or 7 pi over 4 in the fourth quadrant. And it hits 3 pi over 4 first, so now we want to figure out the acceleration at 3 pi over 4, which is negative sine of 3 pi over 4 plus cosine of 3 pi over 4. So sine is positive in the second quadrant, so because we have a negative though here, we're looking at a negative radical 2 over 2 plus another negative radical 2 over 2 because cosine is negative there. So we're getting a negative 2 radical 2 over 2, which is just a negative radical 2. So looking at A. All right, guys, so please let me know if you have questions over any of these. Take your time, even go back and retry these problems. It's always good practice to do that.